Hi everyone, Mr. Barden here. Let's get right on into it. So today I'm going to be exploring a little bit further into the sound portion of the Programming Digital Media course. We're going to be talking about how to set up custom synthesizers and be able to generate audio right from the computer. So up until this point, we've just been playing back previous recordings, applying effects to them, hearing them, sending them different places, all that kind of thing. But now we're going to be actually generating the audio in real time in the computer. One thing that's important to note that I'll get into in a small separate video is that you can still route this audio through any combination of effects that you want. It's just instead of it being a pre-rendered recording, it's going to be made in the computer right here. So I'm going to be going back and forth between a few different things. Some of this will be the tone documentation right here. It'll be this page on the in the class textbook on synthesizers. Those will be the main two things. And then at the end of this video, I will go in and we'll make a synthesizer just right here, kind of live sketching. So I'll come back to this. I've got some parts already made up just to save time. And we'll go from there. So once you've got tone ready to go, there's a few elements that make up a synthesizer. Right? When you break it down to its kind of core element, we have the oscillator. All right, and this oscillator, since we're talking in computers, this isn't oscillating sound. Okay, it's generating a series of numbers that, when sent to the digital to analog converter of your computer to go out the speakers, it will result in electricity to drive the sound. So it's gonna come back and forth, up and down as we go from high to low voltage. Right. What does that mean though? Well, when you look at it, the signal, there it is going to look like one of these shapes. So there's a few different just basic common shapes of these things are called waveforms. Again, the wave being the oscillation here that these oscillators can output. There's some combinations, and you can have multiple different kinds at a time and all of that, but you can combine them and get all kinds of funky shapes. But at the core level, there's basically four main shapes. You have sine, square, triangle, and sawtooth. To kind of just real briefly go through them, the sine wave, it's a smooth curve from high to low. Square just jumps immediately from high to low. Triangle is similar to sine, but it's a direct movement that's not curved like the sine. And then the sawtooth is kind of a combination of triangle and square, so it moves directly from low to high and then jumps back to low. And you can play around with different combinations of these and different ratios to get different sounds and different shapes, but largely speaking, this is the four categories right here. All right. So if you were to go in and make an oscillator, which you can do, in this course I'll just be going briefly over what the oscillators do and how they function, but you're going to move pretty quickly onto the synth objects. But the synths are made of oscillators. These generate sound. Again, by this case, it's generating a series of numbers that then get sent as a signal out to the speakers. It's all converted, and you hear that is being outputted as sound at a certain frequency. In this case, whenever you make an oscillator, you just say it's a new tone.oscillator. You tell it the frequency you want it to oscillate at and the waveform you want it to go. In this case, it is going to be a sine wave at 440 hertz. I'm going to play that right now. You get the idea. It's just the tone, and that's it. You'll notice a few things though. You have the dot to destination, that's normal, and we also have dot start. So the oscillators are they're oscillating, they're moving back and forth. It's just outputting sound for forever. We have to start the oscillator, and then we can go in and say, hey, grab the sound, grab the sound. That's great and all, but it's kind of limited. It's just the sound is always existing and it's always going to be the same. It's either on or off. that's not how synthesizers really work. There's another element involved, and that is the envelope. Okay? So the envelope, if I scroll back to the top, pardon my very fast scrolling, there we are, it shapes the sound when it's applied to this. So we'll be specifically looking at amplitude envelopes in just a second, but I like the graphics on this page a little bit better, just for a generic envelope. So when it's applied to the volume of the sound, that's when it becomes the amplitude envelope. But these envelopes have four main parts: the attack. Okay, so we start it from when we go to 0, ramp to the highest value. The decay, it's going to come down just a little bit. The sustain, so that's just how long everything's sustaining for. The length of the note. And the release, how long it takes the note to decay. Again, you can apply an envelope to a variety of things. It's very easy in Tone to put an envelope on some frequencies or on some amplitudes. In this class, we'll mostly be using amplitude envelopes, which I have right here. So basically, we take those envelopes that we've had before, just on the last tab, and we're applying that to the amplitude or the volume of the sound. Okay, so here we have this tone.amplitude envelope, and we have the attack, decay, sustain, release. Again, those four elements, A, D, S, R. And again, starting at 0, we go up to, we go up. That's the attack. Sustain is going to be the same thing for a while until eventually release, and the sound level comes back down until it eventually hits 0 again, and that's the end of the sound. So by sending the signal through the envelope, we can create notes with different timbres. Having very short attacks makes something, kind of hard and percussive. Long releases, kind of ba. A sustain is just a longer note, like da is shorter than da. That last one having a longer sustain. A longer attack will ramp in gradually. It's like and so on and so forth. I'm gonna stop making noises with my mouth, and that's not what you all come here to do. But so you can do all of this stuff. You can manually hook these up. But what we'll be doing for the PDM class is utilizing the Synth object. And this essentially combines the oscillator with the envelope into one object, which makes our life a lot easier. Let me, again, scroll back up to the top. There we are. So, again, we start here with the one of the oscillator objects, and it runs it through an envelope just natively in here, and then it sends it to the output. And that's really all the object is these two smaller objects combined together. So when we make it, we can just say, hey, play this note for this duration, and it goes everything right from there. So let's look at some codes to kind of see this in action, and then we'll start building up one. So boop. Let's go back up to the top here. So I've got just a real simple code I've made here without, and I'm purposely hiding all this stuff, but you can click and hear it here. But before I get in, I played the one note. That should be fine. I gave everyone a warning. But if you have headphones in, just check your volume. I'll edit all this in post so it won't like blow up any ears. But just when working with these synthesizers, be very careful. If you have headphones or earbuds on, sometimes the volume can be a little loud, and that can blow out your hearing and be not good. So check all that. Maybe take off your headphones if you're in a spot where you can play noises. Just be safe. All right, so I'm going to play this, and it's going to play that same note as before. There's the note. And this is going to be similar to what we'll make in just a second, but ours will be a little bit more interesting. All right, so when building a synthesizer, what we have to go in and do is essentially we need to make a synth object. There are multiple kinds of synths here. If you go into the instrument portion of tone here. There's a few. We'll be again doing synth. There's polysynth, so you can have multiple notes and timbres at the same time. Noise generates noise, mono, metal, membrane, different kinds of modulations, stuff like that. You can play around with all that. And there's also some examples. We're not going to go into it all right this second, because that'll make a very long video. That's what I wanted. But basically, you make the object, and then you can set the various parameters right when you first make the synthesizer. This way, you just do it right when you make it, and that's the starting parameters. You can change them later, and we'll go from there. This uses the JSON notation, again, the JavaScript object notation. And so we'll be seeing that a little bit more with the synthesizers as we get into it. And we can actually see some of that in the code already. Once you make the synthesizer, you just route that either to the destination speakers or through whatever effects you want to go, just like you would any sound file or the player object. We can trigger the sound with the method trigger attack release. And basically that just says, hey, play the sound, play this note, play it for a certain duration. That's it. So you can give it a pitch. There's a few different ways you can represent this actually instead of just a string. You can do it as a string with a note name or as a frequency number. And then you just tell it how long to go for. If I scroll down, again, those note names, you get like C3 and G sharp 7 and stuff like that. Or you can go in with frequencies. So I would say play a note at 40 hertz or 7,000 hertz or whatever you want. You can specify it either way. We'll go from there. So let's look at this object right here. So the first thing we have right here is we are making the new synth, Tone.synth. We're then opening up this object using JSON notation. This actually has objects nested inside of objects. It's a little confusing, but once it works and it's super clear. So we open this up and we say, the parameter oscillator. Well, oscillator has its own set of parameters, and that's going to be type, sine. And then we just make sure all the brackets line up, and we close out. So this will play a sine wave sound. Later down here, whenever a key is pressed, we're going to synth.trigger attack release. That's it. And we're going to play the note A3 for 1 second. So if we look in here and press a key, it plays the note. We don't need to worry about this stuff right now. But yeah, that's basically it. We just specified that, hey, the oscillator, the type of the oscillator of the synth is a sine wave. And then we just later on say, hey, play the note. Just like playing back recordings, you only want to trigger each note one time for each note that you want. You don't want to put this in draw or something, because otherwise it'll trigger the notes over and over and over and over again on an infinite loop, and it's just going to be like, it's going to blow everything up, and you're not going to have a fun time. Okay, so anyways, like I mentioned, all the notes on a keyboard have like a note name and number value. Again, within an octave, you have C, C sharp, D sharp, and so on all the way up through B, and that's all within one octave, so one number. So A0, A sharp 0, B0, C1 is the next octave up. You get then C2, C3, and so on and so forth. Just that's the real short overview. All right. Again, talking about the oscillators in the last one. Again, we specified sine, but you can specify any of these four for an oscillator. Here we can kind of hear the differences between these four kinds with this code. So to kind of go through exactly what we did here, we're just making an oscillator and giving it a default type. And there we go. We've made buttons. Buttons shouldn't be anything new in this course. And they're each set up to a function that changes the oscillator type. So again, we've set it up so that way the number keys each play a unique note. C, D, E, F, G, A, B, C. There you go. And then these functions here, again, are the callbacks for changing the sign. So we just say Basically, it just says, hey, set the synth oscillator type to sine, change the color, and display the what you've selected here, just so it's super clear what we're doing. So click in here. So I'm going to play the scale. There's that. That's on a sine wave. I click square, change the text, the color, and the sound. All right. Triangle. And sawtooth. I'm just playing around at this point, but we can play around with there. I'm not going to get into partials too much, but just know that you can affect the partials of an oscillator, and then basically you can change the levels and get super custom timbres of the sound. Again, that's what I was saying up here. You can change what goes into these. This is just the basic example. Again, I'm not going to go super into that. You can look into that more on your own if you want to. Okay, so that's a super basic overview. I'm going to wrap out this video by making a synthesizer. So I'm going to have a link to this code in the description, this starting one. So if you want to watch this video, go along with me, you're more than welcome to. I'm going to duplicate this just so I don't overwrite that starting code. This is the finished version when I'm done with it. All right, so let's look through what we have here. I've started with just my basic tone template, and I've just added in a variable here that's going to store our synthesizer. Whenever we run this, I've also added in some text. We're going to click the mouse and play a note. That's pretty basic. That's all that's right there. And then I've got this function right here. So we're going to set this up to play random notes. All right, I think that's a little more exciting than just click it and you play a B flat. So yeah, but you could specify just a specific note if you wanted. Just to kind of real briefly go through this, again, just a custom function. We're going to locally define note, and it's going to be a random whole number value between 30 and 5,000. So human hearing goes in between 20 hertz and 20,000 hertz, broadly speaking. I've made this a much narrower range, so that way, if you've got some okay speakers, you'll hear the super low notes. But then once these start getting super high, it can get real piercing, real annoying. I didn't want to listen to that. I'm sure you don't want to listen to that. But you can make this go a much wider range if you want. I'm just also going to display the note, the frequency in the console, and then we'll just return that number as we go. I don't actually think in this course I've discussed the little ticks here, but this is basically just saying, hey, this is a string. And we're just going to display frequency, and then this little bit of notation here basically says whatever is inside of this value, we're going to stick in there. So we're going to say the frequency is whatever is inside of note, which we made right here. You'll see this in a second. That's basically it. We're just going to say, hey, this is the note that just played. All right, so let's do this. You can do this in preload or setup. I'm going to do it in preload just because it exists in my starting template, but it's not going to make any real bit of difference, to be honest. So I'll say synth. So it's going to be a new tone.synth. There we go. I'm then going to open up the object inside of it. I'm going to say oscillator, colon. And then this gets a whole second object, and that's going to be type. Frog in my throat all of a sudden. I'm not editing that out. I have stuff to do later. But type, and I'll make it a triangle wave. That'll be that. And we'll go from there. If I tidy that up a little bit. So again, this can look a little confusing at first, but again, we have the object. It's going to be a new tone.synth. Inside, we're saying, look at the oscillator property, and that property has its own property. So that's why we have to open up another object. And again, it's just the keyword, the name of the property, colon, the value. So type triangle. We'll change up what it sounds like in just a second. We have that there. What we can then do is you can go in and you can connect it right to the destination speakers right now. If you wanted to have more stuff and do it later, you could. I'm just going to do it down here like this, but synth dot tone destination. Anyway, there's multiple ways to connect all this up. I try to mix it up between my videos, so we're going to connect it to the destination speakers. Now, we need to be able to trigger it and play it back, and we want to do that whenever we click the mouse. That's why I have mouse pressed right here. So this is where we'll go up and say synth.trigger attack release. And that's a method. No, come back. That's a method. The arguments for this are the note that you want to play and the duration of that note. So we're going to say the result of function random note, and we're going to run this for 1 second. Just keeping it short. So every time we click the mouse, we're going to trigger that, but we're going to run this function and get a new random note. And it'll then say, hey, play the triangle wave sound like that. So I'm going to click the mouse, and we should start hearing stuff. So that played a frequency of 1,652 hertz. I'm going to click a few more times just to play some more notes. On a low note. Lower. It's basically the same. All right, I'm going to pick a real, just have a bunch of real low ones. Just so we can hear the variety. The higher the frequency, the more change you need before you hear it. So if it's a bunch of lower frequency notes, subtle changes will have a big change in pitch. If you have a bunch of higher notes, you're going to need to move a larger amount of hertz before you hear a pitch. So I'm actually going to make this between 30 and 1,000. But there we are right there. Let's say we wanted to change up the type. Again, you can check out the code we had here for if you wanted to set it up with buttons. I'm just going to manually change it once right here. So instead of triangle, we can just say synth.oscillator.type. It's going to be sawtooth. So now we should hear a different timbre. We'll go from there. If I wanted to make it sine, I'll play just a few more. You get the idea. We can change what this sounds like with this line right here. So again, just to play a basic note, that's all you need is this line right here, this trigger attack release, and you can specify either a random note, a specific note every time it gets called. They can each have unique durations. If I wanted to have a random length as well, you could set that up. It would be a very similar function to this. And, there you go. You could do all of that. That's going to wrap it up pretty much for this video. Just know that, again, you can, in this case, we're just routing it to the destination right here. But you can route this through any series of effects that you want. And that's going to do all of the same things the effects normally do. So what I'm going to do in my next video is I'm going to talk about how you can set up some sequences of notes in order to send those into your synthesizer. That's a little bit of a longer topic, so that's going to be probably a longer video or several videos over the course of a few weeks. But now that you can make a synthesizer, definitely check out the various ones inside of this instrument tab here. Explore, what they have, what they can do. If you wanted to go to just Tone.github.io, there's the examples page, and you can check out what some of these sound like without having to go in and check them all out. So like here's the metal synth, and it'll go into what's combining them, and if we wanted to play it, you can see what these sound like. And again, I'm not going to go into a ton of detail. I'll leave that on you to describe. If you want to comment your favorite synthesizer sound that Tone can do. I love hearing that kind of stuff, or share whatever code you make. Love to check all that out. That's going to wrap it up for this video, so I will see you all the next time that I see you. Bye.